Okay, we are starting off today on page 32. So we're finishing off the kinetic energy of gases today. We'll have a little tiny lesson and then you can work on the exercises. Okay, so this is mostly a review of what we did over the last couple of weeks. The distribution of 3 different gases at the same temperature. So we are all at 300 Kelvin. We have chlorine, which is the most massive. And we have helium, which is the least massive, and we have nitrogen N2, which is somewhere in the middle. Good morning. We're on page 32. That's okay. Okay, and then I'll just replace the wire. Well, that's not really set up very well, is it? There we go, that's a little better. Whoa. No. Okay, there we go. Okay, so at the same temperature, what do you notice about lighter gases? Faster. It's all good. It's all good. It's like when I'm giving directions to someone, I'm always like, it's on your left. Sorry, I meant your right. Okay, so the lighter gases move faster. And why is that? Well, if you remember from last week, and this is not a formula that is given to you on the AP data booklet, but kinetic energy is equal to 1/2 mv squared. So just like Coulomb's law is not given to you, this is not given to you either, and so you're not expected to solve equations with it, but you are expected to know that kinetic energy, what particular measuring thing measures kinetic energy? Kinetic energy, something is a measure of average kinetic energy. Temperature, yes. Okay, so if we have the same temperature, therefore we can say what is the same? The average kinetic energy is the same. And if that's true, then if we have a smaller mass, in order for the kinetic energy to be the same as something with a bigger mass, the velocity of the smaller thing has to be bigger, the velocity of the bigger thing has to be smaller. Does that make sense? Cool. So kinetic energy is dependent upon both the what and the what. Kinetic energy is dependent upon the formula is like literally right here. Mass and velocity. Okay, it's okay. It's first thing in the morning. Velocity. So it's dependent upon the mass and velocity of the particles. And remember that temperature is a measure of average kinetic energy. Yes. You can write in there if you want to. Just take the pages with you when you go. So 2 gases at the same temperature have the same kinetic energy. So at a given temperature, the kinetic energy of A is equal to the kinetic energy of B. Okay, and so we're going to say that B is more massive than A. So what is true then is that KE A is equal to KEB. And so that's the mass of A times 1/2 mass of A times velocity of A squared equals 1/2 mass of B times velocity of B squared. We can get rid of the, actually I should have even gotten rid of the half, right? We don't need a half in the second one, right? Because that cancels out because it's on both sides. So MV squared equals MB squared. So if A has a smaller mass, the velocity must be greater. If B has a greater mass, its velocity must be smaller. Okay, so I've just written that down below there. And therefore, at the same temperature, lighter gases move faster, and heavier gases move slower. And I thought today, there's a few exercises in here. You could spend the rest of the time working through however much you can get through of this, so maybe about 15 minutes or so on this. Okay, and I'll be here to answer questions if you need. Hit some lights so you can see a little better.